Good afternoon to all of you. In the today's online lecture, we have studied the some part of this synthetic drugs and dyes, drug discovery and developments. Next part is the structure modification to increase the potency. This is also one of the important part of this drug discovery. In these parts, involve the position and the nature of the functional groups, nature of the rings, length of the chain, etc., which help in the studying the structure active relationships. This is a study of the hemoglobins, general effect of the carbon length on the drug potency. Hemoglobin series is a group of compounds that differ by the constant unit, generally a CS2 groups. Biological properties of the hemoglobin compound show regularities of the increase and decrease. The process of the increasing the chain length is called as homologations. For many series of the compounds, lengthening of the saturated carbon side chain from the 1 to 5 to 9 atoms produces an increase in the pharmacological effect, but further the lengthening results in the sudden decrease in the potency. The pharmacological activity increase due to the increase in the lipophilicity of the molecules, which help its penetration into the cell membrane, but further the increase in the chain length reduces its water solubility, which will make its transpirations through the aqueous medium difficult, thus reducing the activity. Next point is the chain branching. Branching chain compounds. The branching chain lower the potency of the compounds because the branch alkyl chain is less lipophilic than the corresponding strength alkyl chains. Sometimes pharmacokinetics could become the overriding factor for the potency. However, another explanation for the lower potency with the branching could be the pharmacodynamics. Chain branching may be interfere with the receptor bindings. Consider the example of the phenylethylamines is the having the branching excellent substrate for the monoamines oxides, but the alpha methyl phenylamines is a poor substrate. Primary amines often the more potent than the secondary amines, which are more potent. Is the structure of the two compounds, that is primaquines. The major pharmacological changes can occur with the branching or the homologations. Homologation and the branching of the side chain result in the following changes in the activity. What changes? First, antispasmodic and antihistaminic activity predominates. Antispasmodic and antihistaminic activity reduces, but the sedative and tranquilizing activity are increased. Tranquilizing activity reduces, antipyretics activity increase. This is all about the. Next point is the extension of the structures. For considering that we are taking the examples of the morphine. Morphine is act as the analgesic. In search for more potent analogues, its a ethyl phenyl analogues was prepared which had 14 times greater activity. Thus, by extending the structure, one more binding site has been added which can interact with the hydrophobic sites on the receptor by van der Waals interactions. Next, the important point, that is a computer assisted drug design. This is the most important part. Computer assisted drug design. Computer assisted drug design, also called as computer assisted molecular design, one of the more recent applications of the computers are tools in the drug design process. The computer is only an additional tool to gain the insight into the chemistry and the biology of the problems at the hand, but cannot substitute for a clear understanding of the system being studied. Using the CADD, means computer assisted drug design, attempts are made to find the ligands which will interact favorably with the receptor that present the target site. Binding of the ligands to the receptor may include the hydrophobic, electrostatic, hydrogen bonding interactions. So, based on the amount of information available about the ligands and the receptor, there are two approaches to computer assisted molecular design. Ligand based molecular design, this approach is used when the structure of the receptor is not known. In this case the method are applied. A series of structurally similar compounds have to be identified which exert the different activities, that is high, low, intermediate. From these structures, an attempt is made to identify a pharmacophore. It is a collection of the functional group in 3D space that is complementary to the geometry of the receptor site. This requires a conformation analysis of the molecule to understand their flexible and superimposability. It is assumed that the minimum energy conformers bind more favorably with the receptors. Receptor based molecular design. This approach is used when the reliable model of the receptor site is available. The three-dimensional structure of the receptor and the ligand receptor complex should be provided by X-ray diffraction and NMR studies. This approach involves the use of the molecular modeling techniques to design the ligand which interact favorably with the receptor site. One of the modeling method is known as the docking.
Hi, and welcome to the tutorial that goes along with our computer-aided drug design laboratory experience. In this tutorial, I'm going to show you how to use the myriad different pieces of software that work together to accomplish the drug discovery experience that you've read about in our journal article. I hope this is helpful, and if you need any further guidance, feel free to comment, and I will read the comments and respond as I may. This tutorial is meant to accompany the supplemental information document that was included with our journal article and ought to be read alongside that. In the supplemental information, you will see things about the desktop layout that you'll see in a moment, as well as where to download all of this software and the minimum system requirements for each program. All of the software that we're going to talk about is freely available, and it isn't very taxing on a Marvin Sketch is a very intuitive program, and one draws molecules in this program by simply dragging and dropping bonds. In order to add a heteroatom, you simply highlight a carbon and press the appropriate letter key. I highlighted that carbon and pressed an N for nitrogen. You now highlight your constructed molecule, go to Structure, go to Clean 3D, and Clean in 3D. It then reorientates itself, which indicates that the molecule has been optimized in 3 dimensions and is now ready to load into PyRX. You then navigate to the ligand folder on your desktop, save it as the appropriate format, which is PDB, and call it ligand 5. You can see ligand 1, 2, 3, and 4 have already been added to this folder. And in the bottom left, you can start simply by hitting Start. The first order of business when you open VenoWizard is to upload each of your 5 ligands and also your macromolecule. You can find your ligands where you just saved them in the ligand folder on the desktop. So one at a time, we click them, upload ligand 1, we're going to upload ligand 2, 3, 4, and 5 in the same way. You can see as you upload each ligand, a 3D representation of that ligand is shown in the gray window in PyRX. We now upload our macromolecule, which is histone deacetylase 2, and this is a file that's provided with the manuscript and the supplemental information. You can see hdac2.pdb, hit open, and now we highlight each of the ligands and the macromolecule. Select Forward. This box represents the grid within which the program will look for productive interactions between ligand and macromolecule.
Involves the structural information of the ligand that binds to the target, then that is known as ligand-based drug discovery. Whereas, if the process is based on the structural information of target or the receptor, then that is known as structure-based drug discovery. Ligand-based drug discovery involves processes like QSR modeling, computational chemistry, cheminformatics, drug profile. Whereas structure-based drug discovery involves molecular modeling, protein structure predictions, molecular docking, molecular dynamics.
So this is the understanding part of this computer aided designings totally based on the software. In the syllabus, we don't need to study the syllabus part. It is a further studies for the masters and the research and developments. We need to only understand how the process of the drug discovery takes place, how the use of the computer is there, how the software are utilized. Not need to teach the softwares how to run all these things. Only understand softwares are used for this purpose. For examples, the carbonic anhydrase catalyze the hydration of the some aldehydes and ketones, and the hydrolysis of the alkyl and aryl esters, and also catalyze the reactions. Example is carbon dioxide waters gives the SCO3 plus H plus. It is a zinc containing enzyme about 30,000 Daltons, and the 3-dimensional structure has been characterized by the X-ray diffractions. X-ray diffraction physiologically carbonic anhydrase involved in the gastric, urinary, pancreatic, lacrimal, and the correspondence. Inhibitors of carbonic anhydrase include the aromatic and heterocyclic sulfonamides, and some of these compounds have found applicable as diuretics. Both traditional quantitative SAR and the computer graphics methods have been applied to develop the sulfonamides and other compounds as inhibitors of the carbonic anhydrase. For example, Hans et al. Developed the quantitative SAR based on the binding constant of 29 phenyl sulfonamide to the enzymes. Binding is favored by the electron withdrawing substituent, which is the consistent with the hypothesis that the ionized form of the SO2 binds to the zinc in the active site of the carbonic anhydrase. The Kunz search groups applied their DOX program to the identification of the compounds that may inhibit the carbonic anhydrase. The structure of the two such molecules are shown below. This is the structures of these two compounds. One is the 1-phenoxy 113,6,6 triiodine, then 2,6 27 crown 9s. So these molecules are considerably larger than the aryl sulfonamides that are traditionally used as the carbonic anhydrase inhibitors. In fact, no aryl sulfonamides were identified as a potential inhibitor in this study. This result were obtained probably because the screening of the molecule was based on the size and shape of the molecule. These large molecules can engage in a greater number of the favorable interaction within the large carbonic anhydrase active site at the smaller aryl sulfonamides. This is all about the total topic. So these topics end today. Thank you.